Welcome to The Explainer. I want you to just picture something for a second. Imagine the deep, forested mountains of rural Japan. You've got the wind blowing through the trees, maybe the very faint electric hum of a distant power line. It's beautiful, right? But there is a silent shift happening in these remote areas. And we aren't talking about rolling blackouts. We're looking at a much more profound systemic change, the slow retreat of electricity itself. So today, we are unpacking an absolutely fascinating experiment that could completely redefine how we live at the very edges of civilization.
This brings us to a pretty radical question, one that utility companies are quietly starting to ask themselves. Can a village actually survive without the grid? I mean, for over a century, the rule of modern life has been super simple. Power flows one way. It goes from massive, centralized city hubs, travels across hundreds of miles of transmission highways, and finally reaches the most isolated villages. But what happens when the populations of those distant villages just start to disappear? Utilities are now questioning something that was literally unthinkable 10 years ago. Is it even worth keeping the lights on in places where almost no one is left?
Well, that century-old one-way power highway, it's starting to run in reverse. And that sets the stage for the high-stakes survival experiment we're going to explore today. A group of engineers decided to test what would happen if we just stopped maintaining the grid in these places. Instead, let a village try to survive entirely on its own. It's the ultimate test of resilience. And honestly, the data we're about to walk through is going to completely change how you view the electricity you use every single day.
All right, Section 1. The fading grid, the paradox of rural power.
Think about this small, aging mountain hamlet up in northern Japan. The utility companies there are facing a massive headache of a paradox. On one hand, you have maintenance costs that are just skyrocketing. You've got these huge pylons standing in overgrown forests and transformers servicing houses that are empty for half the year. But on the flip side, as the population drops, electricity consumption is plummeting right along with it. It is becoming wildly expensive and frankly economically irrational to keep a village like this plugged into the main grid. So because of this paradox, utilities are starting to practice this somewhat chilling new strategy. They call it managed retreat. Now, this isn't a sudden failure or a total collapse of the system. It's a calculated, strategic withdrawal from infrastructure that just isn't viable anymore. But we really have to remember the human stakes here, you know? For the elderly folks living in these hamlets, electricity isn't just a nice-to-have convenience. It's their winter heating. It's refrigeration for life-saving medicine. It is literally their lifeline to the modern world. When the lights start flickering, a really deep psychological uncertainty sets in.
Moving on to Section 2. The blueprint, architecture of local autonomy.
Okay, so how do you actually pull this off? To survive full disconnection, the engineers brought in basically three main physical hardware components. Step 1, they set up solar PV clusters specifically optimized to catch that low-angle winter sun. Step 2, they installed a modular biomass generator that actually runs on local forest waste. And Step 3, they brought in massive lithium-ion battery storage to smooth out all the power fluctuations.
But honestly, the physical hardware isn't even the real star of the show here. The true game changer is the digital brain, this proprietary, real-time distributed energy management system. This software is constantly, second by second, balancing the whole shebang. It triages the power. It decides instantly between regular household demand, priority medical loads, heating, battery dispatch, the biomass ramping, everything. It decides who gets power first, and more importantly, it ensures the critical loads never lose it. It takes electricity from being just a basic utility and transforms it into a carefully guarded community asset. Which brings us to Section 3, the climax, executing the islanding protocol.
Picture the engineers in the control room. The system is totally set. You're watching the grid frequency. It reads 50.00 Hz, then 49.98. The tension is palpable. What if we just cut the main power lines right now? The switch is initiated, intentionally disconnecting this fragile little hamlet from the massive national grid. They are now completely isolated, entirely cut off from the rest of the world's power supply.
Now, I really want you to focus on this incredible metric, 0.4 seconds. When they flipped that switch, there was absolute silence and total darkness for exactly 0.4 seconds. Just think about that tiny fraction of time. That was the exact duration it took for the local microgrid to realize, oh, we're on our own, and instantly snap into action.
And the aftermath of those 0.4 seconds? It was a staggering success. The lithium-ion batteries instantly picked up the load, the biomass generator smoothly ramped up its power output to carry the heavy lifting, the solar panels compensated for any lingering fluctuations. The result? Zero blackouts. Literally not even a flicker. The streetlights stayed on, the refrigerators kept humming. Actually, the elderly residents in the village just kept right on watching their television programs, completely unaware that the national grid had just vanished. The islanding protocol worked flawlessly.
Section 4. The secret weapon, biomass and economics.
Now, you'd probably guess that solar power was the hero of this story, right? Actually, scratch that. Processing local forest residue absolutely beats solar when it comes to pure reliability. Biomass has these massive core advantages. First off, it doesn't care what the weather is doing. It provides incredibly stable baseload power, and it runs day and night. Plus, the local mayor pointed out something really cool. The residents used to see this overgrown, aging forest as a huge burden. Now, it's their direct source of energy security, and it even generates new local jobs for maintenance techs and logistics operators. It's a total community revival.
Let's talk money, because the economics of survival here are pretty stark. Maintaining a massive centralized grid means you're constantly extending lines and replacing transformers out in the middle of nowhere. That's incredibly high capital cost with a desperately low return, especially with a shrinking population. On the flip side, look at a microgrid deployment. It's modular, it uses local fuel, it's highly scalable, and the long-term maintenance is super low. In these depopulating regions, centralized grids are just becoming economically irrational. Microgrids aren't just cheaper, they are vastly more resilient.
Finally, Section 5. The resolution, a global blueprint.
We've been focusing hyper-locally on this one spot in Japan, but let's zoom out for a second. This is definitely not just a Japanese problem. Look at-risk hinterlands all over the globe. We're talking rural areas of Europe, remote mountain villages in China, isolated regions of North America. They are all experiencing the exact same pattern, a steady population decline that leads to immense infrastructure stress, which ultimately brings a really high risk of grid abandonment. This successful experiment proves that a decentralized survival architecture can perfectly complement the macrogrid right where it starts to fail.
And this reveals a massive policy implication for governments everywhere. The old methodology was basically maintain everything at all costs, which, as we now know, is financially impossible. The new mantra born from this data? Preserve what can sustain itself. There is an urgent, pressing need to shift our national subsidies away from throwing good money at failing, overextended national grids, and instead we need to invest heavily in these smart, decentralized microgrid architectures.
So, we started this explainer by asking if a village could survive without the grid, but after seeing the absolute flawless success of that 0.4-second islanding protocol, I want to leave you with a much larger and honestly way more provocative question. Should a village even depend on the macro grid in the first place? Because it really looks like the future of energy isn't about building bigger, more centralized systems. It's about building smarter, highly localized ones that don't just collapse when the center weakens, systems that can live and thrive resiliently at the edge. Thank you so much for joining me today on The Explainer, and keep questioning the grid around you.